Okay, hello. Welcome back. We are going to look at these two examples because there's lots of little pieces, and if you've clicked on the video, I know you're looking for an explanation here. We are late in the slides. Some of you are saying we're not late enough in the slides because we're still dealing with this stuff, but we are getting near the end, so hang in there, and we'll look at these couple here as we go. This one here, BEDMAS says that we need to do the brackets first, and you say, well, hold on, these are not like radicals, I can't subtract those. However, we need to start by simplifying the radicals. So that one we can't do anything with. But this one, remember the red in the last slide that I had all these perfect squares? So I could do the square root of 4 times the square root of 5, right? And that's 4, and that's 2 root 5. So now, inside the bracket, I have, remember that's a 1 because we don't show it, but root 5 minus 2 root 5 is going to be negative 1 root 5. And then when I multiply it together, really you're just putting it together, negative 4 square root 5, right? Because this is like 4 times negative 1 is negative 4. And when you multiply, you don't need to have the like radicals, only when you're adding and subtracting. So you end up with negative 4 square root of 5. All right, let's go to the next one here. Root 2, root 10, and root 15. Okay. Root 2, root 10, and root 15. Root 2, root 10, and plus root 15. Okay, plus square root of 15. Now, here I do not have like radicals. I cannot simplify for them to be the same, so there's nothing to do in the brackets. However, I can use the distributive law. Right? I can multiply this times this, and this times this. Right? And remember, when you're multiplying, you can multiply the radicands, 2 times 10, to give you 20. So I have the square root of 20, and 2 times 15, square root of 30. And now I say, well, hold on, can I simplify this at all? Right? Can I simplify this one? And the reality is you can. Now when you look at the slide, I'm looking at the slide, the answer is not really that much nicer. But to simplify it, we saw this one in the last slide, root 4, root 5. 4 doesn't work, 9 doesn't work, 16, 25, none of the perfect squares work. So we're left with this, right? Root 4 is 2 root 5 plus root 30. Okay, and I'll just step off screen for a second. You see, I'm back. You see, it's the same as we had on the slide deck there. And you may be saying to yourself, well, hold on, this does not look much simpler than this. I don't disagree. However, we're simplifying it, and part of simplifying it is getting rid of the brackets and leaving as little as possible in the root signs. And here we had 3 roots with brackets. We're down to 2 roots, no brackets, so we've simplified it as much as we possibly can. And again, these are exact answers, right? You could go to a decimal. It'd be easy on your calculator. 2 root times root 5 plus root 30 and get a decimal answer, which would be very, very close, but not perfectly accurate. Okay, so we'll leave it like this. We'll see you for the next video, which I believe is the last video.